quantum computer doesn't look or act at all like the computers that we use every day. It relies on different laws of physics to run calculations at super fast speeds. Tonight, Google is revealing a breakthrough in the technology that it says could ultimately lead to the discovery of new kinds of medicine or help grow our food more efficiently. Here's ABC's Elizabeth Schulze with a rare look inside Google's quantum computing lab.
It's a breakthrough that could lead to a world once only thought possible in sci-fi. Our exclusive look inside Google's quantum computing lab in Santa Barbara, California.
Not everyone gets to look at these things up close.
Where Julian Kelly is part of a team building this, a quantum computer running on a special chip called Willow.
This chip is what's actually doing all those calculations super fast.
Exactly.
It solved a calculation in just a few minutes that would have taken today's fastest supercomputer 10 septillion years. That's 10 followed by 24 zeros.
We can run it 13,000 times faster on our chip.
13,000 times faster than a regular computer with this.
Not a regular computer, the world's largest supercomputer.
Wow.
Now, we're the first to see how it's reached a major milestone. A new algorithm Google says provides the instructions to a quantum computer for making discoveries about the fundamental properties of Earth and human systems.
It's one more step that shows that quantum computers will be able to make useful predictions that are beyond what classical computers could ever do.
If it sounds complicated, well, it is. Quantum computing relies on a totally different set of scientific rules than the classical computing we're used to on our laptops or phones.
Explain in the simplest form what that set of rules is.
So in classical physics, a ball can be in one location or another, but not both. But in quantum physics, a ball can actually be in both locations at the same time, or what's called a superposition.
You mean two places?
A metaphor that I like to use is, a classical computer is more like a car that you drive to get from point A to point B. You drive it around to, go to the grocery store, to the airport. A quantum computer is like a rocket ship. It can travel really fast.
In other words, this isn't...
That's where Google's announcement comes into play. Executives say its new algorithm could take quantum computing out of the hypothetical and into the real world in fields like agriculture or drug manufacturing.
What are some examples of how this could be used in actual real life?
A quantum computer could actually be critical in the drug discovery process. What the pharmaceutical companies have to do is they do a lot of trial and error. They make different drug candidates. Some of them work and some of them don't. What a quantum computer could do is it allow you to focus on the ones that are much more likely to succeed and less time kind of going through trials that wouldn't work at all.
Is it a stretch to say quantum computing could save lives?
Absolutely, yes.
Not a stretch at all.
It's not a stretch at all.
We AI in 2012.
I like to go to the edges of human experiences early.
From other tech titans like Amazon, Microsoft, and IBM to young startups and universities, an intense competition over the future of quantum computing is well underway.
Every part of it has to be really good, because if in one seemingly mundane piece not working, and the whole thing will not work.
A lot of this apparatus...
Inside the lab, we get a glimpse of just how complicated it is to get quantum computers to work without any errors. One of the key challenges that must be resolved before they can live up to their potential.
The quantum computers we make operate at very low temperatures.
So put our goggles on.
We pour liquid nitrogen over a fresh flour. Within seconds, it's completely frozen.
And that's around minus 200 Celsius or minus 300 and something Fahrenheit.
What is happening to this flour?
Yeah, so it's getting quite cold.
Wow.
And you'll see that, for example, now this thing is very brittle. So if you just kind of touch it,
It completely crumbles.
it completely crumbles. So that seems pretty cold, right?
Freezing.
Freezing. So this is actually way too hot for our quantum computer.
Crispy.
It takes 4 more stages of cooling to get a low enough temperature for the quantum computer chip, stored at the very bottom of the base, to behave.
Every one of these plates gets colder, 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 until this volume down here is basically one of the coldest places in the entire universe.
So you need to keep it cold so that the actual chip works the way you want it to work.
Exactly, that's right. Decades ago, people would have to build these systems in their own physics laboratories and a very bespoke thing, and now actually there's an entire industry of different suppliers that sell these dilution refrigerators for the quantum computing industry and also just for scientific research purposes.
They're banking on this being the future.
Right, yeah.
But just how soon that future will arrive is up for debate.
Companies like Google have said this technology is life-changing. Is that hyperbole?
So I believe eventually that will be right. It's the time scale that's more the question. I wouldn't bet on it being life-changing in the next 5 years, at least for everyday users.
And when that day comes, there's a big danger from quantum computing that we should all be preparing for now. We asked Google if quantum computing is the next AI.
It's a little bit comparing apples with oranges. So it will not supplant AI. Quantum computing will enhance AI and allow it to solve problems that AI on classical computers would not be able to solve.